Welcome to your video on writing equations for lines. Up to this point, we have been working a lot with linear equations, and we have been primarily graphing them and solving for line. So today you're going to learn how to actually write the equation for a line given information. This first slide just goes over the three different types of lines, and we've talked about these before. We have diagonal lines, horizontal lines, and vertical lines. For diagonal lines, you will notice that they will have an x and a y in them, and we'll end diagonal lines in slope-intercept form. You should recognize y equals mx plus b. Horizontal lines only have a y in them, and we've been saying that y is just equal to a number. That number happens to be the y-intercept, so if you know the y-intercept, you can plug that in. But it's just going to be y equals a number. You will not see an x in that equation. Vertical lines, on the other hand, only have an x, and so we have been saying that x is equal to a number, and that number happens to be the x-intercept. We used to plug letters in for these, but sometimes that's confusing, so just think of it as just going to be x as a number. It's just going to be the x-intercept. So we have three different forms for a diagonal line. Now remember, diagonal lines have an x and a y. The first is the one that we're going to work with almost all of the time, and it is called point-slope form. It looks like this. It's called y minus y1 equals m, and then there's parentheses x minus x1. Now the reason this is called point-slope form is that you're given a point, x1, y1, and you'll recognize that just from our slope formula again. You just take a point and you label it x1, y1, and then m obviously is the slope. So there it is, point-slope form. So when we write equations, we're actually always going to use point-slope form, but your answer will never end up in point-slope form, and we'll show you how to do that. What your answer is going to end up in is in slope-intercept form, and you've seen this many, many times. Slope-intercept form is y equals mx plus b, where again m is the slope, and 0b is your y-intercept. Remember, your y-intercept always has to be an ordered pair. Now, standard form is not something that we are going to write our equations in, but sometimes you're going to be given an equation in standard form and then have to get it in slope-intercept form. So standard form is ax plus by is equal to c. I just wanted to put that out there because you'll see equations written in standard form, but in this class at least you won't have to ever put one in standard form. So let's get started here. For diagonal lines, and you should have a big box in your notes here that kind of goes over this. For diagonal lines, the first step that you want to do is to find the slope. So you might recall the slope formula, y2 minus y1 over x2 minus x1. And I know some of you are flip-flopping that and saying y1 minus y2 and x1 minus x2. That's fine too. So you have to find the slope, but you don't always have to find it. Sometimes it could be given to you. The problem might just say, here's the slope. So if that's the case, then obviously you can just ignore this step. After you find the slope, what we're going to do is plug into point-slope form. So let's just write down what point-slope form is again, just so that you have it in a couple of places. So you can kind of see what's going on here. The directions say choose a point. Now, if you were given 2 points and you use those 2 points to find the slope, you just have to choose one of those points, and it doesn't matter which point you choose. Just pick one of those points and plug the x value in for x1, plug the y value in for y1. Obviously you're going to plug your slope in for m. Once you've plugged those in, then your last step is to solve for y, which just means get the y by itself. So what you'll do is you'll distribute the m, and then once you've distributed the m, you're going to add or subtract y1 to get that over to the other side, depending on what the sign of y1 is. And again, these steps are just guidelines for you. We'll go through some very specific examples that will help you. But your final answer must be in slope-intercept form, which again, you should recognize as y equals mx plus b. For a horizontal line, it's y equals a number, and again, our number is the y-intercept. So let's just graph a horizontal line here. You'll notice that a horizontal line will only cross the y-axis, unless of course it is the x-axis itself. But so if we put a little dot there at the y-intercept, we could label that point 0b, And actually, when you do y equals a number, it will equal the y-intercept. Sometimes you might see in a book, it might say y equals b. But the two important things that you need to keep track of for a horizontal line, and write this nice and bold here, is the slope is 0, and that all of your y coordinates are the same. No matter what x is, your y value is going to be the same because that's what keeps it on that horizontal line. Okay, so we're going to look at vertical lines now, and you're going to notice some similarities here. A vertical line is x equals some number. And we'll draw a vertical line here, and you'll notice that the vertical line crosses just the x-axis. We sometimes label the x-intercept a0. You've seen that notation before. So sometimes you'll see x equals a, but it's x equals a number. X equals the x-intercept, however you want to think about it. The two important facts that you need to know for vertical lines is, one, that the slope is undefined. Don't say no slope. No slope can be confusing. You have to say the slope is undefined. And then all of the x coordinates will be the same for a vertical line. So you have to know how to write 3 different equations for a diagonal line, a vertical line, and a horizontal line. So let's look at some examples. Here we are given a point, or the line contains a point, and right away I'm going to label that. Let's call that x1, y1. And then we're told that we have a slope of -4. So let's label that -4 with an m, or let's write down m equals -4. Now, if you recall, our first step in writing a diagonal line was to find the slope, but in this case it was given to us. So what we can do now is we can jump right to step number 2, which was writing it in point slope form. So let's write down the general form again, y minus y1. You're going to get sick of this, but you need to memorize this. Write that down, and then start plugging stuff in. So we've got y minus a -7, because y1 is a -7, and we'll simplify that in a second. M is a -4, and then we've got x minus 1, because that was x1. So let's simplify this a little bit. On the left-hand side, the minus the negative will cancel, so we have y plus 7. On the right-hand side, we're going to distribute the -4. So we have -4x plus 4. And now to get y by itself, we're just going to subtract 7. Now remember, we can only subtract 7 from the like term, so only combine it with the constant. And then by doing this, we're solving for y. We're actually going right ahead with step 3 here. And then you can circle that final answer, because that is it. That is slope-intercept form. And you'll recognize that the slope is a -4 and the y-intercept is a 0, -3. All right, our next example, write the equation for the line that contains these 2 points. So the first thing we're going to do is label again, x1, y1, x2, y2. And this time we have to find the slope. So we're going to go back to our slope formula. We're going to do m equals y2 minus y1 over x2 minus x1. So that's 1 minus a -2 over -6 minus 3. And really be careful with your negatives here. So again, we have a double negative. So we're going to cancel that out, and it would end up being 1 plus 2. So we have 3 over -9, which reduces to a -1/3. Okay, so we found our slope. Now we're going to put it into point slope form. We just have to pick one of our points. So since point slope form uses the y1 and the x1 notation, let's just put a box around the 3, -2 to indicate that we're picking that point to plug in. So we have y minus y1, so it's y minus the -2 equals -1/3, and then in parentheses, x minus 3. So to simplify this equation, on the left-hand side, we're going to change that to y plus 2. And then on the right-hand side, we are going to distribute. So it's -1/3 x plus, because we have a double negative, and then a third of 3 is just 1, so it ends up being 1. And then our last step is to subtract 2 from both sides. So our final equation is y equals -1/3 x minus 1. You always want that final equation in slope-intercept form. Next problem. Write the equation for the line that has a rate of change of 1.5. Rate of change is just a fancy way to say slope. So m is equal to 1.5. So that's good, because our first step was to find the slope, and it was given to us. So now we also want to note we've got this point, so label your point x1, y1. and then go ahead and jump right into point slope form. So it'd be y minus 5 equals 1.5 multiplied by the quantity x minus 4. So we don't have to do anything on the left-hand side, just bring that down. Distribute your 1.5, so we have 1.5x minus 6. And then add 5 to both sides to isolate your y. And our final equation is y equals 1.5x minus 1. Slope-intercept form is again our goal. Right, our next example, write the equation for the line that contains these 2 points. So again, we're going to have to go back to finding the slope. So we're going to label our points here, and then we're going to plug those into the slope formula. So we've got m equals negative 6 minus 7 over 3 minus 3, which gives us negative 13 over 0. And right here, we're going to run into some trouble. Our slope is undefined. So let's write that down. It's undefined slope. Now, if you look back at our notes here, the kind of line that we're looking at is a vertical line. So let's write that down. We've got a vertical line. And vertical lines are always x equals a number. And if you look at our x coordinates here, and let's just circle those, our x coordinates are all the same as something else that we wrote down. So x here has to be 3. Now, some of you are going to be really observant, and you're going to notice right away that your x values are the same. You can jump right to your final equation if you catch that, because if your x values are the same, you know you're going to have a vertical line. So you wouldn't even have to show that your slope is undefined. All right, our last example, write the equation of the line that has an x-intercept of 3 and a slope of negative 5. So this is really tricky. An x-intercept is really giving us a point. And you have to remember that an intercept has a 0 in it, and because it's the x-intercept, that means that y is 0. So what you want to do is you want to translate that to your point, your x1, y1. And then we're lucky because we're given the slope again, so we know that the slope is negative 5. So we plug stuff into our equation here. It's y minus 0 equals negative 5 times the quantity x minus 3. Now, we distribute, so we can still do y minus 0. And we end up with negative 5x plus 15. Now, some of you are saying, well, why did we write minus 0? We could just drop that. And you are correct. But others of you like to follow through everything the same way. So you could technically add 0 to both sides if you wanted to, although we know that that doesn't make any change. So our final equation is negative 5x plus 15. All right, you are now ready to begin your practice. The first worksheet just has a couple of problems on it, but make sure that you're working all of them through because they each have a little different twist.